I'm going to talk about increasing annuities, and we're going to do a few examples. I think now is a nice time to recap what an annuity actually is. So an annuity, it's a series of regular cash flows that we receive for a lump sum of money or however we're financing it. But what I want to stress now is that these annuities, they're not all the same, right? So all of them, they've got their own custom terms, meaning the different timings, durations, the amounts, and the investment environment, how interest rates can change, and growth rates. But you'll see that when we go through questions. So let's start with the first one. A dividend is expected to be paid in 3 months' time at an amount of 10 Rand. Dividends are expected to grow at 5% per annum. The interest rate is 1% per month. Dividend payments will end 10 years from now. So dividends are typically annually. So assuming that a dividend payment is annual, that's very viable. And then I noticed straight away that we're given an interest rate per month when we're working with per annum. At least the growth rate is per annum. So let's quickly just change the interest rate into per annum. Pop that in the calculator. Remember to just carry on as many decimals as you can. So now while we're doing this, let's just quickly work out J. Remember, when we're doing increasing annuities, we're always working out J. And the formula for J, let me write it on the side. Right. So J is equals to, what's I? We just calculated I. So I'm just going to say, I'm not going to rewrite that long number. Growth minus 1. So pop that in a calculator and our J becomes cool. So let me just get rid of this thing. Sorry. All right, where were we? Okay, so calculate the present value of this thing. A dividend is expected to be paid in 3 months' time. So what we can do is we'll do a timeline here. What I want to do, if this is time 0, we need to present value it to this time. But our first payment is in 3 months. It was given as $10, and we know that it's growing. So 10 times our growth, 10 times our growth squared, and we have 10 payments. So our last payment over here is going to be 10 to the growth to the 9, because our first payment, which is in 3 months, is 10, and they mentioned that we in 10 years. So after 10 years from right now, so 10 years from here, we would have received 10 payments. So let's jump into it. So I'm going to first work out the present value to this point, and we can just discount that 2 times 0. I think that's going to be the easiest. If you've got a different way to do it, we'll see if we get the same answer. So present value at time 3. I'm not going to write this long J out. I'm just going to write J. You know what it means. Right. You should remember this formula by now. 1 plus I to the negative n over 1 minus 1 plus I to the negative 1. So that's that formula. So let's just pop this quickly into the calculator, and this J being this that we calculated. That's going to be cool. So now we have present value at time 3. So to get present value at time 0, which is the one we want, we're going to take this answer and we're just going to discount it by the 3 months. And I'm using 1.01 because 1% is the monthly interest rate. So we can just use that one, unless you want to use the yearly one, but then you wouldn't have -3, you had a negative 1 over 4. Yes. So now pop this in a calculator, and our answer is 72.09. That is our answer for the first question. Let's move on to the second one. An annuity is expected to pay its first monthly payment in 5 months at an amount of $100 in advance. The first 10 payments will grow at 3% each time and then remain constant for another 10 payments. Interest is 1%. So there's a lot happening here. I even see two. So it's deferred, and now we've got two different. Okay, let's start with our first payment in 5 months at time 5. First one is 100, and then it's growing for the first 10 payments. So there'll be 10 payments. It's growing till time 10. So then we'll have that amount, which is going to be 100, grow to the power of 9, and then we're going to stay constant for another 10 payments. So all these payments, another 10 of these ones, g to the 9, 100, g to the 9. This is not time 10. Let me fix that quickly. This would be time 15. What's happening? Yeah. 15, and then this would be 25. Right. So there's a lot happening. Let me just, interest is 1% per month. We need it in are these payments monthly? Expected to pay first monthly payments. Yeah, so we leave interest. I just like writing it there so that it's clear. So we need to eventually get it to time 0. So what I want to do is I'm going to first present value these growing ones, the growing annuities, the first 10 payments to that time, and then I'll present value these 10 payments to this time, and present value discount those two values back to time 0. So let's start with the present value at time 5. That's going to be, we're starting with 100. Those are in advance, that was stated. Advance, there's 10 payments at growth J because they're growing. So J, we already spoke about the formula of that. Pop that in the calculator. Cool. Now let's just oh, that was a bit squished, but I'm sure you know what I'm writing there. Cool, so that's the present value that we have here of the 10 payments that grew. So now let's get the present value of time at time 15 of those 10. But let's quickly calculate what that payment is at time 15. So our 11th payment, what's that going to be? 11th is going to be, take 100 and we'll grow it 9 times. I'm just using the growth. That's going to be equal to put in the calculator. So don't get confused. Don't think that this should be a 10 because remember these are in advance. So the first payment was not grown and there's 10 payments. So therefore there's only 9 spaces for growth. Cool. So now what we're doing, now we're getting present value at time 15. Present value at time 15. To this bit. 10. And now I'm just going to use the 1%. There's no growth. So we will just be chilling here with this interest rate of 1% per month. So now it's that long number, and we'll put the formula. So pop that in a calculator. We get cool. So now we have those two. However, we need to present value both of these, discounted both to time 0. So present value at time 0 is going to be the 1093. 9813. Right, that's that value. And this we need to just present value 5 times by 5 months. It'll be 1 negative 5. And then this value we're present valuing this one 15 times. It's that times 15 months. So pop these two into the calculator. Cool, and that is the answer. Let's move to the last one. The present value of a 2,400 per annum payable annually in arrear for X years and increasing at 5% per annum is 21,000 something something. 10% interest rate effective annually. Calculate X. That was a mouthful. Present value. Okay, so this is a annuity payable annually in arrears for X year. Okay, we need to calculate basically how many payments, how many years, but we're increasing, so we're working with J, but we have present value. So let's start with that. The present value was given as 21,579, and the first payment would be 2,400, and we're working in arrears, so we'll use the one without the dots. We don't know what the term is, put X there, and we're working with J. Let's quickly calculate J. J is equals to, wow, what interest is 10? Okay, so, hey, this is, okay, I haven't done one like this. 1.05, so this should be negative. Let's put in a calculator quickly. Tripping. Yeah. So now that we have J, we can go back to this equation. I'll rewrite it 21,579. This formula is 1 minus 1 plus J to negative X over J. I'm not going to rewrite J, that's a long number, but you know what J is. And now we can start doing some math. So we'll divide by 2.4k, so that gives us remember X is the variable we're trying to work out. We have J. J is this number. So we'll just multiply. So that's going to be I'll put a natural logarithm this side. Natural logarithm. Right. Let's put this in the calculator. Divide them out. So X is equals to 12.01. We'll just take X is equals to 12. Cool, that's the answer. I hope this helped. Keep well.